So throughout the year, we've talked about the three congruence transformations. They're reflections, rotations, and translations. And basically, anytime we subject a polygon or a point or any number of points to these transformations, the thing that we end up getting is congruent to what we started with. So in this problem, I've just asked that you go through and kind of identify where point C is after each one of the transformations. You can sketch the whole shape or just part of the shape, but we're going to start with the original point C, and then we're going to reflect across the y-axis. Then we're going to rotate 90 degrees clockwise, and unfortunately I need to say about the origin. So that's important that you know that you're rotating about the origin, otherwise it changes. And then finally there's a translation here, and there's a rule for the translation given. So if I start with C at this point, and I'm going to reflect across the y-axis, as I reflect across y, everything's exactly the same distance it was from y on the other side. So this is 1 unit, so this is where C ends up coming. Here we've got 2 units, so this is where this point goes to. And then I could go over 2 more points, and that would be this point. And then from point C, I guess this would be C prime after I move it, I could go over 1, 2, 3, 4, 5 more points. 1, 2, 3, 4, 5 more points, and this would be that final coordinate. So you can see after my reflection across the y-axis, this is the I guess this is a trapezoid. This is the trapezoid I would get. And C, the point, ends up going to the point 1, 1. So if I'm tracking C, C prime, right, after one of the transformations is located at 1, 1. Now I've got this point, and I'm asking, well, what happens now as I move this point forward? So the next transformation that I'm supposed to do is I'm supposed to rotate this 90 degrees clockwise about the origin. So if I'm here and I'm going to go 90 degrees this way about the origin with the entire shape, remember what happens with slopes, right? Slopes become opposite reciprocals. So if you look at this, the slope from the origin to 1 is up 1 over 1. Well, that means the slope after the rotation is going to still be 1 and 1, but now one of those has to be negative. It's going to be over 1 down 1. So this is where C is going to go. So this will now be C double prime. This is the second stop that it'll make in its trip. If I want to write the rest of the points, right, you can go through and consider each of them. This point right here is up 3 over 2, up 3 over 2. So what I'm going to do is go over 3 and then down 2. So this is that point, right? That's the point right there. Maybe a color coding would help, right? This point in orange started right there. I could do the same thing with another point. I'll just sketch this right here. This is up 3 over 1, 2, 3, 4. So what I'm going to do is I'm going to go over 4 and then down 3. I'm so sorry, this is up 3 over 4. So now I'm going to go over 3 and down 4. I'm sorry, I have to flip them. So over 3 and down 1, 2, 3, and 4. So this point right here corresponds to that point. And then a final one, I'll use purple. Again, I'm just looking at these slope patterns. This one's up 1 and then over 1, 2, 3, 4, 5, 6. So now I'm going to go ahead and go, I'm going to go down 6, 1, 2, 3, 4, 5, 6, and then over 1. Except I didn't go down 6, did I? I went down 5. I'm saying the right thing, but I didn't draw the correct thing. So it was up 1 over 6. Now I'm going to go instead down 6 and then over 1. So I end up with this new trapezoid here. This is what it looks like after this rotation of 90 degrees about the origin. This origin is my center of rotation. And then when I'm done with that, you'll notice that C double prime now is located at the point 1, negative 1. Now I'm going to do this one last time. The last thing that I'm asked to do is to do I'm going to translate by a vector. And it says every xy that you have, you're going to take your current x value and you're going to subtract 4. And you're going to take your current y value and you're going to subtract 2 from that. So subtract 4 from x and subtract 2 from y. So if I'm here, and I'll do this one with black, I'm going to subtract 4 from the x, and when I subtract 4 from x, it goes back to 1, 2, 3, 4, and then it says to subtract 2 from the y. So I'm going to go down 1, 2 for y. So this is that point after the transformation. I'll do the same thing with the point that I've marked in orange. I'm going to go back 1, 2, 3, 4, and then I'm going to go down 1, 2 points. Same thing with the point that I've labeled in green. I'm going to go back 1, 2, 3, 4 points, and then I'm going to go down 1, 2 points. And then finally, the one that's in purple, I'm going to go back 1, 2, 3, 4 points, and then I'm going to go down 2. So this is my final trapezoid. It ends right here. And the point that I've been tracking the whole prime C is now triple prime, and that's located at the point -3, -3.